continuation to our lecture, we have here the third requirements for highway, design requirements for highway under AASHTO. We have the minimum radius of curvature. When we say minimum radius of curvature, recall that the radius of horizontal curves in engineering surveys will be applied to a highway as shown in the right figure, where RV is equal to R minus half of the lane width. Minus half of the lane width. So once we have computed the curvature of our road, or the minimum radius of our horizontal alignment, gamitin lang natin yung R minus half of the lane width. Ito lang naman yun, no? Ang basis lagi natin when we are deciding horizontal curve is the center of the lane or the center of highway. Kung 2 lane yan, doon tayo sa gitna. Doon tayo magbe-base ng segment or ng segment. Then half of that will be the basis on our SSD as shown in the given figure. Okay? So for instance, ito yung ating highway, center line, your back tangent and your forward tangent, the critical section. So SSD is identified here. Then site obstruction, RV. Ito ngayon yung radius on the SSD design. Okay? For the minimum radius of curvature for horizontal curves derives now as the initial velocity squared over 127 times E plus F times S. Minimum radius, na-compute natin yung actual radius ng ating roadway. Now, with the involvement of the velocity, the super elevation, as well as the friction and the tawag na dito, the coefficient side friction or skid resistance, eto ngayon yung ating minimum radius when it comes naman sa SSD. No? Gaano kakapal yung kailangang i-occupy ng left lane doon sa curvature na yon. So we have here the design speed on kilometers per hour, which we have identified kanina. Super elevation, meter per meter. Angle of friction, alpha. The coefficient of side friction or skid resistance. And the minimum radius of curvature. And this is how are we going to do that. Remember, roads are not totally flat. No? Meron tayong allotted inclination for it to reduce the speed of the vehicle and to maneuver properly whenever it is passing a curved road or a horizontal alignment road. So basically yan lang naman yan. W resultant alpha plus theta WV squared over GR. Tangent alpha plus theta gives us WV squared, or the weight of the vehicle passing to that horizontal curve times its actual velocity or design speed over g times the actual radius all over weight, gives us the angle of inclination for it for the roadway plus alpha is equal now to the design speed squared over g times r. Continuation by trigonometric identities, sum of two angles. Tangent theta plus alpha is simply equal to tangent theta plus tangent alpha over 1 plus tangent theta and alpha. That is basically your identities, no? Then, applying your trigonometric analysis, resultant in the presence of friction with the contact of the vehicle with the pavement, tangent alpha is basically Fs over N. Tangent alpha is now Fs. Negligible yung ating normal force. Then, tangent theta plus alpha is the super elevation E plus Fs over 1 minus E times Fs. E times Fs is almost equal to 0. So, never mind. So, tangent alpha plus theta is E plus Fs over 1, where V squared over GR gives us E plus Fs. The tangent theta is now computed as the super elevation specified on the design over 1. Video on the purpose of using super elevations on our roadway are shown or is already included in our module. Kindly use that link for you to furtherly gives you knowledge on understanding the purpose of super elevation. In continuation, here we have R. R now is basically your minimum radius of curvature. And R minimum is equal to design speed V squared over G times E times plus Fs. or R minimum, converting that, kasi English unit yan, convert lang natin siya sa, ang tawag na dito, sa metric. So, V squared times 1,000 over 3,600 squared. That is now our minimum V squared over 3.6 squared, or basically 127 times E plus Fs, which is now, in return, gives us our minimum in meters. Then lahat yan naka-kilometers per hour na for conversion. And tangent theta V squared over GR is the ideal angle of embankment. So how do we inclinate the road on horizontal curves or on vertical curves as it tips or performs skidding? Then tangent theta and alpha V squared over GR, the maximum speed at which a vehicle can maneuver a curve without skidding. Okay? As an example, on the minimum radius of curvature, we have here an application number 1. The rated speed of a highway curve of 100-meter radius is 65 kilometers per hour. If the coefficient of friction between the tires and the road is 0.60, what is now the maximum speed at which a car can maneuver the curve without skidding? So, without skidding, remember yung formula natin kanina. Without skidding is tangent theta plus alpha V squared over GR. So without skidding, we have tangent theta plus alpha V squared over GR. That is tangent alpha of 0.6, which is your between the tires and the road. Coefficient of friction between the tires and the road is 0.6. And the alpha is 31 degrees, which 31 degrees. Tangent alpha is now equal to the actual speed of 65 over 3.6 squared kasi PPH squared para maging meters, then 9.1 meters per second squared times 100 meters gives us alpha theta of 18.4. Then for the actual design speed, that is 18.4 degrees plus 31 degrees. That is now equal friction. Remember, friction F tangent alpha, tan 18.4 plus 31 degrees gives us V squared over 9.81 over 100, which is basically 33.82 meters per second at a maximum, convert lang natin yan, of 121.75 kilometers per hour. On the second application, we are now asked to determine the radius of a horizontal curve for a design speed of 50 kph as specified by the specification in lateral friction and super elevation. Given yung ating design speed, then sundin daw natin yung specification ng design speed, which is on table 6.4, values of side friction F. Design speed is at 50 kph. Hanapin natin. 50. Walang 50. Nasa 48. So, ang friction natin is at 0.16. Okay? The maximum super elevation E must be between 0.6 to 12% as per required by AASHTO for the maximum super elevation. So, we are going to use between 6 to 12. So, use na natin yung minimum na 6%, which is 0.06. Substitute, 50 kph is found on this column under 48. So, gagamitin ng friction na 0.16. So, 127 minimum super elevation, 0.06 plus 0.16 gives us a minimum radius of curvature on SSD at 89.48 meters. Okay? Considering all the forces acting on the vehicle when negotiating horizontal, it can be shown that the required minimum radius of curvature is given by V squared over 127 times E plus F. Remember yung ating maximum minimum ES of super elevation. Pag lumagpas sa maximum, gamitin yung maximum na 12%. Okay? Pag lumagpas naman sa minimum na 6%, gamitin yung 6%. Or meron pa yung isa na 2%. Now, where V design speed in kph, E is the super elevation, F is the side friction. The table below provides the values of F for different design speeds. Values may be interpolated between on the design speed used, lalo na kung nasa gitna. Kaso kanina 50 more than. So kaya diretso na tayo sa 16. So if our design speed is at let's just say 75. So between 74 and 80. So between 74 and between 64 and 80, that is 0.15 and 0.14. So with interpolation, makukuha nyo yung side friction. Okay? Now refer to this module on table between English units and metric units. For using English unit, ito yung ating reference for the design speed in miles per hour, maximum E, super elevation, limiting values, the total Fs, calculated radius, rounded radius. Marami yan. Nasa module nyo po lahat yan. Di nagkasya sa slide. So, paki-check na lang or itabi nyo na lang dun sa module. Now, as per the continuation on our lecture, we have now the discussion on assigning or computing the super elevation, which will be the next part of our lecture, which is part 4 ng ating Module 1, Unit 2, Design Requirements for Highways. I'll see you on our next lecture video. Bye-bye.